All right, let's run through another Mtel question. This one says the edges of a small cube are scaled by a factor of 4. How does the surface area to volume ratio for the larger cube compare to that of the smaller cube? All right, so we're talking about two different values here. We're talking about surface area and we're talking about volume of a cube. So I think it's probably pretty important to have those equations. So surface area, which I'll just call A, of a cube is the area of each face, and there are 6 faces on a cube. If you think about like a die or a pair of dice, they have 6 sides, right? So it's going to be 6 times the area of each side. Area of a square, which is what each side on a cube is just the side length squared. So surface area is just A equals 6 times S squared. Volume of a cube is just a side length cubed. I think probably the easiest way to think about this is to plug in random numbers and see how that affects that ratio that they're talking about. So what they're saying here is that they're multiplying the value of the sides of the cube by 4. So if we just use 1 as our initial side length, we can calculate these values. So if we had a side length of 1, our surface area would be 6 times 1 squared, which is still 6, right? 1 squared is 1 times 6 is 6. And our volume would be 1 cubed, which is just 1, right? So the ratio, so it says surface area to volume ratio initially. So the ratio is 6 over 1 for the smaller cube. So I'll write that up here. If S equals 1, ratio equals 6 over 1, right? Then let's run that same calculation with a side length of 4. So 4 squared is 16. 6 times 16 is 96. So quick calculation there, right? You got that. So 4 squared is 16, then we're doing 6 times 16. So our area would be 96. And volume is just 4 cubed. 4 cubed is, so 4 times 4 is 16. 4 times 16 is 64. So now our ratio is 96 over 64. You can definitely simplify that a little bit. That's going to be 6/4 or 3/2, right? Yeah, so 32. 32 goes into 96 3 times. 32 goes into 64 2 times. So this is 3/2. So up here we can say if S equals 4, ratio equals 3/2. And then they want us to compare the ratios. So how does the ratio compare for the larger cube compared to that of the smaller cube? So the ratio is smaller by a factor of 4. So the larger cube definitely has a smaller ratio, right? This is the larger cube. This is the smaller cube. 3/2 is definitely smaller than 6 over 1. And how much smaller is it? What do we have to divide 6 over 1 by to get to 3/2? 6 over 1 is just 6. If we divide 6 over 1, if we divide 6 by 4, we get the fraction 6 over 4, which is the same as 3/2. So we can tell that the ratio of the larger cube when compared to the smaller cube is smaller by a factor of 4, which is answer A.